the properties of a joint. Few properties are already known to you. You have seen those property. You have used those properties. It's given in your book. It was there in your syllabus as well. And few are very new to you. Okay, but today we will not be discussing that from where these properties came. Okay, you just need to take it as it is, just like a formula, that these are the formula, and if the question will come, we will be using the formula or the property as it is. Okay, so let's see one by one quickly. This first property is already known to you, right?
Yes, ma'am.
Yeah, so let's see it quickly. So the first one, a, if you will multiply with the adjoint of a, that is same as adjoint of a multiplied with a. But this two both, when we will solve it, will give us the result that determinant of a multiplied with the identity matrix. Identity matrix, the order will be same as the order of a. Okay, here when we are talking about the matrix, here the order of the matrix, it's a square matrix, n by n matrix, or you can say m by m matrix. It's a square matrix we are saying, and that's why in the next few properties you can see the exponent is n minus 1, or maybe the exponent is n minus 2. So basically this n came from the order of the matrix. Okay.
Yes, ma'am.
Yes, Meera.
Yes.
just now uh just now I started just sharing the screen and we have started the discussion. So this is the property of adjoint. I was saying that few properties are already known to you and few are new to you. Today we'll not be having the discussion that from where these properties came. We will be using this property, we'll be taking it as it is, like a formula. Okay, so these are few properties. If you want to take a screenshot, you can take a screenshot. If you are already having the all the property together in one place, then that's great. So these are the properties. Okay, apart from these, okay, we also have few more properties, but basically these are the few properties related to adjoint. We also have properties related to determinant. We also have property related to inverse, but those are like 2 3 properties, those are known to you. Okay, and we'll be using, if not, then we'll be using it while doing the question, and I will tell you that note down there is a property like this one as well. So yeah, let's start with the discussion. Okay, so the first question here says that there exists a matrix P. We can clearly see it is 3 by 3 matrix, is the adjoint of a 3 by 3. So this P is a joint of a matrix A. Okay, so however the name is given as P, but this is adjoint A, right? Right?
Yes,
Yes,
ma'am.
ma'am.
Okay, and determinant of A is already given. We don't know what is A. A we don't know, but adjoint of A we know. Okay, a matrix is given to us. Determinant of A, that's value also we know as a 4, and we are supposed to find the alpha value from here. So we are thinking, is there any property which is related to adjoint and the determinant of A? Let's check it in our property, this sequence. So adjoint and determinant. Adjoint and determinant. Can you see this property number 2? If we are having the adjoint, then we can find the determinant of that, right? On the left side. And then the determinant value which we are having,
Yes, ma'am.
we can use on the right side. Getting it?
Yes,
So
ma'am.
you just need to learn,
Yes,
memorize
ma'am.
formulas, okay, these properties, and we'll be using it as it is. So it says that when we are having a joint A, then what we can do, we can find the determinant of that matrix. So basically we can find the determinant of that P, and that we can compare with the determinant A to the power n minus 1, where n is the order. We are always talking about the square matrix, so here n value is 3. So determinant A to the power 3 minus 1, that means determinant A is square, and here determinant A value is given as a 4. So basically it is nothing but 4 square. And adjoint of A, that's determinant you will be able to find, right? By using the basic, just you need to expand it, you need to do the simplification. Will you be able to do?
Yes, ma'am.
Yes, ma'am.
Okay, so this question was really simple. Let's do the next question. Here a matrix A is given. Okay, whatever be the matrix, or matrix 2 by 2 matrix, as we can see it's given, and another matrix B is given 2 by 2. Okay, what is I? We understand that. However, it is defined over here as well. And it says that Q is this one. Okay, Q is A transpose B A. This is Q. Then the inverse of matrix this. Yeah, we have to find inverse of this matrix. A Q to the power 2021 A transpose, and that's inverse we have to find. So everything is fine. Okay, we know what is A. We know what is A transpose. Okay, we'll be able to find A transpose. But what about this Q to the power 2021? What about this Q to the power 2021? And this is, if here Q would be given, then we would have thought about the pattern based question. Okay, that Q is given. Let's check what is Q square, what is Q cube. But here we don't know Q. Okay, you can see A we know, the matrix A we know, matrix B we know, but Q we, this type of expression is given for Q. Proper matrix we don't know. Is it possible to find? Yeah, but it would take time. Okay, doing multiplication of three matrix like this, it would require time. We are having a square matrix, we can do so. Yeah, you can do so. If you are not getting anything that how to do this question, then you can do that way as well. And then Q to the power 2021, again it will take time, but better if we will think about using this property, we'll be able to minimize time. Okay, so let's see, Q is given as this one. If we will be finding Q square, so it is, can I write it as A transpose BA multiplied with the same A transpose BA? Can I write it this way?
Yes,
Or
ma'am.
no?
Yes, ma'am.
Okay, we can write it. Now let's open the bracket. In matrix, while doing matrix multiplication, we cannot randomly switch the terms here and there. Just like the algebra, we cannot do so. So carefully we will open the bracket and we will not drag any matrix from here to there. We cannot do so. Okay, this is what we are having. I have not changed the place of any matrix, right? Now we can see here A into A transpose is there. We know A, okay? A transpose also will be able to find, right? Right?
Yes, ma'am.
Yes, ma'am.
So let's find A transpose and let's see what exactly is the value of A times A transpose. So here our matrix A is given as 1 over root 5, 2 over root 5, and here minus 2 over root 5, and here 1 over root 5. This we will multiply with A transpose. So we'll be having 1 over root 5, 2 over root 5, minus 2 over root 5, 1 over root 5. Right? Upasna and Meera?
Yes, ma'am.
Yes, ma'am.
Let's do the multiplication quickly. So this will be having 1 by 5. And this with this will be having plus 2 by, oh no, 4 by 5. Yeah. This multiplied with this will be having minus 2 by root 5, and this with this will be having plus 2 by root, not root 5, just 5. Yeah. This is what we are getting, right? Please check it. Are you getting the same?
Yes.
Okay, so 4 plus 1, 5 by 5, we can say 1. This is 0. This is, we can say 0. And this is, we can say 1. So we ended up getting an identity matrix of order 2 by 2, right? Right?
Yes, ma'am.
Okay, so A into A
Yes, ma'am.
transpose, this one is nothing but just identity matrix. Okay, B identity matrix, again B, A transpose over here, A over here. That's our Q square. Okay, so what we can say, if we will pre-multiply here by A, like this, both side, we can do so, right? In matrix, we do either pre-multiply or post-multiply. We have to mention it specifically. Do you know that? Okay, so here, see, in matrix, we don't do the multiplication randomly. Anywhere we will just multiply. We are just multiplying this A pre-multiply, because you know that A, B and B, A are not same always. Always it is not same. So if you are doing multiplication in the same manner, you have to do it. A, we are multiplying here pre-multiply. As the name says, pre-multiply we are doing, and here also pre-multiply we are doing. This way we are not changing this equality. Is this still valid? Is it making sense?
Yes, ma'am.
Okay, now this A into A transpose is again I. Any matrix multiply with I is the same matrix, right? Right.
Yes.
Yes, ma'am.
So here we are just left with B. Okay, and this B is also here. We can write it B square, of course. And this A is here. And here we are having A Q square. And now we will do post multiplication, because this A is there on the other side. If we will do post multiplication with A transpose, here also post multiplication with A transpose. Why we are doing so? So see carefully the part which was asked to obtain. Does it looks like somehow same as the way we have made it? Can you see it?
Yes, ma'am.
Yes.
Okay, that's why that is also giving us the hint that let's proceed in that manner. And yeah, this I is also giving us the hint that yeah, okay, we can go ahead in this direction. So we are doing the same again. This is identity matrix. So basically we are getting B square, that is A Q square A transpose. So what about A Q to the power 20218 transpose? So see, if Q square is B square, then Q to the power 2021 will be B to the power 2021. Yes or no? Yes or no?
Yes.
Okay, we are going to
Yes,
get.
ma'am.
So now B we know. B we know. And how to get B to the power 2021, you know that. Okay, in matrix we have done the discussion that this pattern based question, separately also it can come, or while solving another type of question we can encounter such scenario. If we have to guess what is B to the power 2021, we will be finding B square, we will be finding B cube, and I believe that much will be enough to say what is B to the power 2021. Let's check it quickly, because it's square matrix, it would not take that much time. So if we'll be finding B into B, that is 10I1 with 10I1. Okay, let me write 1 0 0 I 2I 1. This is B square. Let me check B cube as well. And yeah, please check it. Okay, whatever I have obtained, are you getting the same? Okay, so have you got the same, Meera and Upasna?
Yes, ma'am.
So can you see the pattern? 1 is there, 0 is there, then 2I is there, then 1 is there. Then 1 is there, 0 is there, 3I is there, then 1 is there. So we'll be able to find, okay, B to the power 2021, we will be able to find, okay, 1 will be there, then 0 will be there, then 2021, I will be there, okay, according to the exponent, and then 1 will be there, right?
Yes, ma'am.
Yes, ma'am.
Okay, this is our A Q to the power 2021. A transpose. Okay, A Q to the power 2021 A transpose. This is the matrix we have obtained for that. But be careful, we are supposed to find the inverse of that. So if you know the matrix inverse, you will be able to find inverse of this matrix. right? 1 by determinant of A into adjoint of A. And since it is a square matrix, inverse is really simple, right?
Yes.
Yes, ma'am.
Okay. So yeah, this is how we'll be dealing with this question. Again, here you can see we are specifically doing the matrix multiplication, but carefully we are doing, okay? Here and there, just like algebra, we cannot do matrix multiplication. Next, let me read it. If it is really simple, I'll leave it for you. If the matrix A is given as this one, and if A inverse is this one, if A inverse, which you will be able to find with the help of the given matrix A, okay, right? Inverse you will be able to find of the given matrix, right?
Yes, ma'am.
Yes, ma'am.
And that is given as alpha I. I is identity matrix 1001 plus beta A. Beta into A is given over here 1 2 minus 1 4. Okay, beta is just like scalar multiplication, you can do it. Alpha also is scalar multiplication, we can do it. And then equality of matrix, we can do the comparison on both sides, right? Right?
Yes, ma'am.
This is really simple. Okay, much more tougher than this question you have done in NCRT. So yeah, this one is simple. Next, if let A and B be two 3 by 3 real matrices such that A square minus B square is invertible matrix. If A square minus B square is invertible matrix, that means the inverse exists for this particular matrix, right?
Yes, ma'am.
Right? Yeah. And if one of the condition is given, this A to the power 5 is same as B to the power 5, and A cube B square is same as A square B cube, then find this value, A cube plus B cube. But just by seeing this two equation, we can do the addition of this two equation, we can do the subtraction of this two equation. Here A cube plus B cube we are supposed to find. So let's add this two and let's check. Okay, are we getting anything? Or maybe we will be doing the subtraction also and we will check it. Okay, both way we will check it, which one is helping. Okay, you can see factorization is clearly, we can see here that yeah, factorization is possible, we can take out common factor. But see what is ours, A cube plus B cube. So we will try, okay, after factorization we will try creating this A cube plus B cube as one of the bracket. Okay, let's check it. So if we will take from here, we can take A cube common. From here we can take B cube common. If we will take A cube common, we are left with A square plus B square. Fine. Okay, and this all, let's bring it to this side, this everything. So minus will be there. Minus B cube we need to take out common, and we will be left with B square plus A square. Right? Right?
Yes, ma'am.
So you can
Yes,
clearly
ma'am.
see we are getting A cube minus B cube over here and A square plus B square over here. But we are supposed to find A cube plus B cube. Okay, so and the other one also, this A square plus B square we are getting. But in question why it is given that A square minus B square is invertible. So maybe the other scenario, this is not helping us, maybe the other one will help us. So here if we will take A cube common, we are left with A square minus B square. B cube common, we will be left with B square minus, yeah, I believe this one will help us. A to the power 5 minus A cube B square minus B to the power 5. After splitting the middle term, how you do the factorization? Basically, that only we are trying to do over here. Okay, so we will take A cube common and we are left with A square minus B square. Okay, this matrix is invertible, it is clearly written in the question. So maybe we need to use that information here. If we will take out minus B cube common, we are left with, let's take just B cube common. Okay, because both bracket we need to maintain same, right? Right, Meera and Upasna?
Yes,
Yes,
ma'am.
Okay, so minus B square plus a square. Can you see we are having both the brackets are exactly same, right?
Yes, ma'am.
Okay, so we will not get confused. We are having a cube plus b cube, which we have to find, and we are having a square minus b square. Now in question clearly that is equals to 0. In question clearly it is written that a square minus b square is an invertible matrix. If it is invertible matrix, then we can do the multiplication of inverse of this on both sides, right? Right,
Yes,
because
ma'am.
it exists, so we can do the multiplication. And a into a inverse is identity matrix, right?
Yes.
Yes, ma'am.
That is equals to again 0. So what is the value for a cube plus b cube? 0. Getting it?
Yes,
Yes,
ma'am.
ma'am.
Okay, we have not done anything, we have just done the just basic, the way we work with algebraic equations. Okay, we have added them, we have subtracted them. Okay, and since it was clearly written in the question this is invertible, so we are thinking that why it is written in the question. Okay, that's why we have done the multiplication of inverse, and that's how we ended up getting this a cube plus b cube. Okay, this type of question we
Yes,
have
ma'am.
discussed in the last, in our first class, the matrix class. Okay, how to create matrix when this type of uh like it is defined like this, like a function, that when I is smaller than z, then this is what we are going to take, when I is equals to z. So let's take it, because I can see here we have to work with the properties, okay, which we have discussed initially. So for that reason only I'm taking this question. If I'll find that yeah it is really simple, I'll leave it. So A11, okay, I and J are same 2. A22, 2. A33, 2. Right? Meera and Upasna?
Yes, ma'am.
Yes, ma'am.
A12. 1, 2 means I is smaller than Z. When I is smaller than Z, then minus I to the power Z minus I. Okay, this place is A12. So this J, okay, Z is 2 and I is 1. 2 minus 1 is 1. Minus 1 to the power 1 will be negative 1 only. Getting it?
Yes,
Yes,
ma'am.
ma'am.
A13, again I is smaller than J. Okay, so minus 1 to the power 3 minus 1 is 2. So plus 1 basically will be happening. Now this one, A21. I is bigger than Z. So minus 1 to the power I plus Z. Minus 1 to the power 1 plus 2 will be 3. So negative 1 will be happening. This one. Okay, let's write the last one. So A21, A22, A23. Okay, again, this is A23. So here again, I is smaller, right? So negative 1 to the power 3 minus 2, 1, negative 1. The last one, A31, A32. Okay, so 3, 1 is there. I is bigger, minus 1 to the power I plus j plus 1 will be having, 3, 2 we are having, again bigger. So minus 1, 3 plus 2, negative 1 will be having. Is it clear to both of you?
Yes, ma'am.
Yes.
We ended up getting our matrix. We have to find this one, determinant of this. Okay, that means we have to find determinant of this. Okay, so let's write it. Determinant of 3 adjoint to A inverse. This is what we are having, right? Right? Determinant sign I have given.
Yes, ma'am.
If you are having, do you know any property when you are having determinant of Ka? It can be written as K to the power what? N.
And
Okay. Determinant of A, right? So if we are
yes,
saying
ma'am.
that it is determinant of K, and this all is A. So we can say it is nothing but K to the power N. What is the order? Order is 3 by 3 matrix we are having, right?
Yes.
So 3 and determinant of A. That means our A is this, the circular part. A joint of 2A inverse. Is it clear so far, Meera and Upasna?
Yes, ma'am.
Yes, ma'am.
Getting 27 over here. Now this one. Let's check our formula book. That is there any formula for determinant of a joint? So yes, we are having. Okay. Determinant of a joint, again the same formula. Okay. The same property which we have already used. Determinant of a joint is same as the determinant of A, that's power n minus 1. So you can call it B or P for a while. So basically you are having a joint of P, that's determinant. So for that we'll be having determinant of P, that's to the power n minus 1, right? Right? That means
Yes, ma'am.
3
Yes,
minus
ma'am.
2 and 27 will remain as it is. Okay, now let's put the value of P. P is nothing but 2A inverse. 2A inverse. That's square is there. Okay, square can be written as determinant is just a value for us. Okay, and that's why we can write it as a 2 inverse. That's determinant. And again, 2 inverse. That's determinant. Making sense?
Yes, ma'am.
Okay, now 27 we are writing as it is. And again, we are going to use the same logic. Determinant of K into something is there, no? K into something. So this K will come out taking the power. So 2 will come out taking the power 3. From there also, this 2 will come out taking the power 3. Is it making sense?
Yes, ma'am.
Okay, and we are having this one. And determinant of A inverse can be written as 1 by determinant of A. Do you know that? Do you
Yes,
know
ma'am.
that? Then we are done. Do we know A? Yeah. Is it possible to find the determinant? Yeah. Right?
Yes.
Yes.
So it's clear, right? This is how we just need to use the properties. So you need to memorize properties really well. Okay, it must be on your tips and then you need to use it as much as possible. So this question, it's crystal clear, Meera and Upasna.
Yes, ma'am.
Yes.
Okay. Okay, let's move. Let's do this one. Let's let A be 3 by 3 matrix such that a joint of A is given and B is given. See, a joint of A is given. We don't know what is matrix A. A joint of A we know. Okay, a joint of A is this one and B is this one. Okay, we have proper, okay, so many properties. We'll be using that if required. Here, what we are supposed to find. See, the determinant of A is a value and that value here is given represented by lambda. Then determinant of this B inverse transpose, this is a value. Determinant of something is just a value for us. And that value is represented by mu over here, right?
Yes, ma'am.
This one, for now, do you know that determinant of A transpose and determinant of A is the same value? Do you know that?
Yes.
Okay. So if we know that, at last we have to find the determinant only. So this transpose, even if we are not writing, it's completely fine. We can write C, B inverse. That's determinant is mu. Can we say so?
Yes, ma'am.
Okay. And this B can be written as 1 by determinant of B. That is mu. So far we are understanding this much. We don't know whether it is going to help us or not, but so far we are understanding this much. Now a joint A is given and determinant of A is lambda. So again we are thinking, is there any relation between a joint and determinant? So again we will be able to recall the same formula, this one, right? Right?
Yes, ma'am.
Okay, a joint of A, that's determinant, we'll be able to find the value. Let's find it. Okay, because here we need it, then only we'll be able to say what is lambda. Okay, so determinant of A, at the place of that I am writing lambda. Since it is 3 by 3 matrix, so 3 minus 1 will be 2. So basically lambda square is the determinant of that adjoint matrix. Okay, let's find the determinant quickly. So 2, 0, plus 4. Please keep on checking, okay? Otherwise we will end up doing mistake, and then after that back to back we will getting everything will be incorrect. So yeah, here plus 1, this is going 1 minus 2, and then plus 1 again, this 2, and here 0. So we are getting 8, we are getting minus 1, we are getting plus 2. Are you getting 9? 10 minus 1, yeah. Are you getting 9?
Yes, ma'am.
Okay, so we are getting this determinant of the given adjoint matrix. Determinant of that is 9. So lambda square is 9. So lambda can be plus 3 or lambda can be minus 3, right?
Yes,
Right?
ma'am.
Okay, what we are supposed to find over here, this ordered pair, where lambda is given inside the modulus. Okay, the mod of lambda we need to take. This is not determinant of lambda. Okay, we need to take the mod of lambda. Lambda is just a value for us, a mod of that value. So plus 3 minus 3, we have obtained the value. If mod is there, then we will be saying this in this ordered pair 3 will be there, right?
Yes, ma'am.
Now mu, what is the value of mu? So we also have one relation. Okay, that B is nothing but a joint of adjoint A. So here for mu, determinant of B, in that format we have written. Okay, so we also have a property. Let's check it. There is a property where a joint of a joint A, that matrix, that's determinant is there. This one. Can you see? If we are
Yes,
taking
ma'am.
a joint of a joint, say, okay, already finding a joint A is a tedious task. And after finding from matrix A joint of A, again one more time you will be finding one more adjoint. It will be really time taking. Okay, so you can see properties are there, property 3, property 4, which will help us simplifying this tedious task. So if we are taking the determinant of a joint A, that is same as determinant of A to the power n minus 1 is square. Okay, so we can say that here, yeah, here, that if we will take determinant on this side, if we will take determinant on this side, this adjoint of adjoint A, it is same as, okay, determinant of A to the power n minus 1, that means 3 minus 1, that is 2 square. Getting it? Getting it? I am talking about this one. Are you
Yes,
getting?
ma'am.
So we can say, okay, that B is nothing but this determinant of A, that's to the power 4. B is nothing but determinant of A to the power 4. Determinant of A we have got. Okay, that was lambda, but lambda value we have obtained plus 3 minus 3. If you will be taking any 3, power 4 will be positive. 81 you are going to get, right?
Yes, ma'am.
Okay, so yeah, we'll be using this value over here. Yeah, okay, determinant of B is same as determinant of the other side is same as 81. So determinant of B 1 by 81 we can write, that is mu. Is it making sense?
Yes, ma'am.
Okay, we got mu, we got lambda. Our ordered pair will be 3 comma 1 by 81. So see what we did. What we did. At first, a joint of A was given. At first, we can see in this question, a joint of A is given, and it says determinant of A is lambda. So we are thinking a joint determinant, a joint determinant. Is there any property? We are using the property. Just after using the property, we ended up getting the value of lambda. Okay. After getting the value of lambda, we are keeping it aside. Now we are thinking why this condition is given, that B is a joint of a joint A. B is a joint of a joint A. So we are using again a property that if we will take the determinant of a joint A, that means determinant of B, that is same as, okay, determinant of A to the power 4, that means 81. And then we got lambda and mu value, we got the ordered pair. Crystal clear?
Yes, ma'am.
Now we'll be doing this question. It's from, as you can see, it's from relation and function. Relation and function, okay, already you are having, you know the concept of that. There is nothing extra which you need to know, which you need to learn. Everything, okay, you, the way you were doing the analysis while solving question previously, same way we will be following the same way right now as well. Okay, whatever be the type of question. So it says that which of the following is not, it's not correct for relation R on the set of real number. It's not correct. Okay, so xy belongs to R. Okay, xy belongs to real number, such that this is neither transitive nor symmetric. See, checking checking reflexive is really simple. Checking symmetric is also simple. Transitivity, I have seen a student little bit, okay, they get confused, right? Right.
Yes, ma'am.
Okay, so we will see, we will check the option where reflexive symmetric is there. First we will take that option, because quickly we will eliminate the option, because we have to check which option is not correct. So reflexive symmetric, last one. Okay, option number D, I am starting from here. Okay, you can see reflexive symmetric will be able to analyze directly and quickly. So it says that mod of x minus y is smaller equals to 1 is reflexive. Yeah, it is reflexive, right? It is reflexive, right?
Yes, ma'am.
Okay. And is it symmetric? Yeah, it is symmetric as well, because mod is there, right?
Yes, ma'am.
So this is correct. We are checking not correct. Okay, let's see here reflexive symmetric it says. So mod of x minus mod of y, this is smaller equals to 1 is reflexive. Yeah, this is also reflexive, because 0 we are going to get, and 0 is smaller than 1. That's fine. What about symmetric? So if we are having mod x minus mod y, that is smaller equals to 1. So you will take mod of any number. Think about it. It says it is not symmetric. Okay. You will, suppose you have taken example that you are having just inside the mod, you are having 2 or maybe minus 2. Okay. Here you are having minus 3 and you are doing the subtraction. Okay. So 2 minus 3 is negative 1. That is smaller equals to 1. Okay, that is correct. But what about this 3? Okay, this example I must not take because it is valid. I must take a bigger number, 4 over here. 2 minus, yeah, okay, 2 minus 4 is negative 2 and it is a smaller equals to 1. And if we will just exchange the place, it will not be the same, right? Are you getting it?
Yes,
4
ma'am.
minus 2, it's 2, which is not smaller than 1. Okay, so when we will change the place, since the mod is, we have separated the mod, it will not be symmetric. Is it making sense, Meera and Upasna?
Yes, ma'am.
Okay, so this is also correct.
Yes, ma'am.
This is also correct. Next, B. Here symmetric transitive we have to check. So xy belongs to R such that mod of x minus y is symmetric. Okay, yeah, it is symmetric because inside the mod we can change the place and doesn't matter. So it is symmetric. Okay, this is true. And it is transitive as well. Transitivity we have to check carefully. So mod of x minus y, it's lying between 0 to 1. We can say for xy, when xy belongs to r, then we can take by ourselves. If yz belongs to r, then y minus z will lie in between 0 to 1, right? Right?
Yes, ma'am.
We have to check xz, that is valid or not. Okay, so better think about an example rather than doing the calculation. Mod is involved, so you will be adding them, subtracting them, and even after that we will not be able to take x and y. Okay, so let's take example. Let me take a random example. 2 3, 2 minus 3, 3 4. Let me check just a moment. No, 2 minus 3 we are getting, yeah, this is okay. And 3 minus 4, this is okay. And what about this 2 and 4? 2 minus 4 is 2. Yeah. Can you see? Can you see? Randomly I have picked an example. Just randomly. Is it transitive? Is it transitive? Is it true or false? 2 is smaller than 1?
No, ma'am, it's false.
Okay, it's false. So not correct we were searching, and we were eliminating the options, and we ended up getting that the correct option is B. Okay. So this is false and the correct option is this one. Got it?
Yes, ma'am.
Next. Let n be the set of natural number and a relation R on n defined by this. A relation is defined like this. Set of all ordered pair xy belongs to natural number such that x cube minus 3x square y minus xy square plus 3y cube is equals to 0. Okay, let's move. So whenever this type of relation is given, previously you have solved this type of question, but that time x minus 3y is equals to 8. So we used to write x is equals to 8 plus 3y like this, right? To check what are the ordered pairs, right?
Yes, ma'am.
Okay. But here, even if
Yes,
the terms looks like so many terms are involved, we will try doing the factorization, which will give us clarity. Okay, how the x and y is getting added, subtracted. So we will check if factorization is possible or not. Okay, so this is not x minus y whole cube formula. As you can see, if you will see carefully, you will understand 3y cube is there. So this is whole cube formula is not there. Okay, now if I am taking, just a moment, let me check. If we will take x square common, we'll be having here x minus y. And if we will take from here y square common, no, 3. Okay, here 3 we are getting 3y. Here also we'll be getting x minus 3y. Yeah, can you see we are able to do the factorization, right?
yes, ma'am.
X minus 3y, x square minus y square, and is equals to 0 is there. That means x minus 3y, in one bracket x plus y, in another bracket x minus y. I have expanded this one, is equals to 0. This is giving us clarity, okay, that something into something into something, that is equals to 0 means any one of the bracket, or maybe all of them will be 0. In mathematics, one fundamental is there, that that I'm talking about basic algebra, not matrix. Okay, in matrix A into B is 0, then it is not mandatory that A will be 0 or maybe B will be 0 matrix. It is not mandatory. But with normal like real numbers, or maybe if we are talking about the variables algebraic, in algebra, when we say that x into y is 0, that means maybe x is 0 or y is 0 or both are 0. Do you know that if something into something is 0, that means any one of the number over here has to be 0, because It doesn't works like that in real world, that two numbers which are non-zero but the result we ended up getting zero. It doesn't works like that, right?
Yes, ma'am.
Okay, you can think about any number, very smaller number, negative number, positive number, but the product will not be zero if those two numbers are non-zero. The product will be only zero when one of them is zero, or maybe both are zero. Okay, so if we are saying that this bracket, that bracket, that bracket are zero, so now we will keep this, we will use this logic that either the first bracket will give us zero, that is fine, or maybe all the brackets value will be zero, and accordingly we will be thinking about the ordered pair. Now we have to check, is it reflexive or not? So reflexive means what? If x and y are same, right? So if we will take x minus 3x, this bracket is not giving 0. If we will take x plus x, this bracket is not giving us 0. If we will take x minus x, yeah, this bracket is giving us 0. It is fulfilling the criteria of reflexivity, right?
Yes, ma'am.
Yes,
Got
ma'am.
it. Okay. So this is how we'll be checking. It's, again, I'm repeating, it's not mandatory that all of them has to be zero. No, any one of them is zero. That means, yeah, the result will be zero. Other side we are getting. Okay, now symmetric. If we will place y over here and x over here, we can clearly see it will be a different number. Okay, if we are talking about real number, definitely it will be different number because modulus and all is not involved. Okay, and multiplication of 3 is also there, so it will be different number. This x plus y and y plus x will be same. Okay, this is same, and this x minus y, y minus x again will be different, completely different. Okay, so without even taking example, are you understanding that it will not follow symmetry, the condition of symmetry?
Yes, ma'am.
Okay,
Yes.
Yes,
we
ma'am.
cannot say, even if we are not thinking about example, we cannot say that x minus 3y and y minus 3x is the same thing. Okay, we cannot say that x minus y and y minus x is the same thing, so no symmetry. We will check the example now, I mean the options now only. If any option till here will click, okay, we will mark it. So symmetric but not transitive, this option is completely incorrect because we got not symmetry and reflexive. Okay, reflexive but neither symmetric, so this can be, we are keeping it in the category of can be because transitivity is still we have not checked. Okay, reflexive and symmetric, this is incorrect. And equivalence relation, no. Option B now only we can mark, right?
Yes.
Okay? Because the most appropriate option after checking reflexivity and symmetry, we ended up getting yes, it is reflexive, yes, and no, it is no, not symmetry. So on the basis of that, option B is correct. Got it?
Yes, ma'am.
Let's move. You just have to search from your question paper. You just have to quick. You have to scan the paper and you have to search the questions which easily you will be able to solve quickly at first, and then you can think about those questions, okay, which you can but require a little bit of time or understanding. Okay, so this type of question you will be having in your question paper. Let A is given as this one, and this is equivalence relation. We understand what exactly is the meaning of equivalence relation on A by A. Okay, A cross A defined by AB is related. Okay, an ordered pair AB is related with ordered pair CD if and only if AD and BC are same. Okay, which satisfies this equivalence relation. So this is the relation with ordered pair 4 3 is equals to, okay, which, let's read it carefully. Then the number of ordered pair, how many ordered pairs are there which satisfy this equivalence relation with 4 3? How many ordered pair will be there which will satisfy, okay, which will be related with this 4 3? So if you are saying 4 3 is related with CD, that means this condition must be followed. AD is equals to BC, that means 4D is equals to 3C, right?
Yes,
right?
ma'am.
Okay, that means we can say, d is same as 3 by 4 c, right? Right.
Yes, ma'am.
Okay, and as you can see our set A, okay, A, B, C, D, everything we must pick from the given set A, 2, 3, 4, 5, 6, 7, 8 till 30. From set A only we need to pick. That means we must think about whole numbers, right? Right.
Yes, ma'am.
Okay, let's create ordered pair. The condition is D must be 3 by 4 C. Okay, whatever ordered pair we will be creating, every ordered pair must be related with this 4, 3. Let's create ordered pair. So CD we have taken. We have taken the assumption that let's assume that ordered pair CD is related with 4, 3. So now we have to write that CD. Okay. So if we will be taking, we cannot take C as a 2, right? Because then we will be getting D as a fractional number, which is not there in A, right?
Yes.
Yes, ma'am.
So we must take this C as a any number which is completely divisible by 4. So then only we'll be able to remove this denominator 4. Okay, and D will be a proper whole number. Okay, so 4 we can take, C value 4 we can take. Okay, so if we are taking 4, D is coming as a 3. Okay, we were thinking about 4, 3. So yeah, 4, 3 again is we ended up getting. Next, C we can take 8 over here, right? Right. Then D we
Yes,
are
ma'am.
getting 6. 8 we, if we are taking C as a, yeah, 8, then D we are getting 6. If we are taking C as a, or 3 times 12, then D we are getting as a, or 3 times 12, 9. If we are taking as a 16, see I'm just reading the table of 4 and accordingly I'm taking the number. Okay, and before 30 I will stop. Getting it?
Yes, ma'am.
Okay, so for 4 times 16, 12. Okay, if we are taking this as a 20, then 15. If we are taking as a 24, 18. If we are taking 28, then 21. After that I cannot take, right? Because till 30 we are having the numbers in set A. Getting it?
Yes.
Yes, ma'am.
Okay, so let's see how many ordered pair. 1, 2, 4, 3 we will count. Yes, 4, 3 we will count because equivalence relation. Okay, same, this the same ordered pair is related with itself. That is the case. Okay, so 1, 2, 3, 4, 5, 6, 7. Total 7 ordered pair we have obtained. 1, 2, 3, 4, 5, 6, 7. Can you see?
Yes, ma'am.
Okay, then the number of ordered pair which satisfy this equivalence relation. Okay, with ordered pair 4, 3, there are 7 ordered pair which will satisfy the equivalence relation with 4, 3. Got it?
Yes, ma'am.
Yes.
Okay, we are almost done. This is the last question we'll be doing. Quick, quick, quick. So here our relation is defined as a PQ. Okay, where P and Q are at same distance from the origin. Okay, so P is a point, Q is a point, and the distance from the origin O, the distance of P, the distance of Q are same. So if you are saying P is A comma B and Q is C comma D, so basically in a statement form it is written that P and Q are at same distance from the origin. In mathematical language we can write it. The distance formula, if we will use, it will be A square plus B square, and this is C square plus D square. Yes or no? Because origin is 0 comma 0, right?
Yes.
Okay, so in statement form it is
Yes.
written like this. If we will be writing it in mathematical language, then you can say that under root this A square B square has to be same as C square plus D square. That means root we can remove by squaring both sides. A square B square has to be same as C square D square. This is just the mathematical format we have written. Okay, be a relation, then the equivalence class of 1 minus 1. Equivalence class of 1 minus 1 means class you have learned already in relation chapter, that what are, just like the previous question, what are those ordered pair which will be related with 1 minus 1, right? Right?
Yes, ma'am.
Okay, so if you are taking this CD as a 1 minus 1, then distance from the origin will be under root. Okay, uh, it will be 1 minus 0, that is 1 square, 1 minus 1 minus 0, that is 1 square, so under root 2 we are getting, right? And according to the
Yes, ma'am.
defined relation, under root a square plus b square is equals to under root 2. It has to be, right?
Yes, ma'am.
Okay, that means a square plus b square is equals to 2, squaring both sides. Now, whatever, all those ordered pair AB which will satisfy this condition, we can say those are related with 1 minus 1. Yes or no?
Yes, ma'am.
Yes, ma'am.
Let's see the options, because here nothing is defined. So set of all ordered pair xy related with which will follow x square y square 4. No. Okay. 1 no. This option D. Can you see? All those xy we will take which will satisfy this condition, and we are also on the same page. We are saying the same thing, right?